Hi everyone, I'm Krystal, and I've been working as a creative coder for about 12 years now. During this time, I've had the opportunity to do a little bit of everything from web and mobile application development to 3D modeling and VR. I'm also part of the Insights team at Shopify, where we do everything related to data viz and analytics. Today, I'll walk you through some of the techniques that I've learned along the way so that you can create your own reusable and performant charts and animations in your React applications. If you have any doubts, questions, or suggestions, please do reach out to me on Twitter. My username is Krystal Campioni. Before we start talking about code, I would like us to go through a concept that is really, really important. Motion is a message. If you think about it, the way that it works in real life is that, things don't, pop in your face because it would be super scary if they did. Instead, what happens in real life is that things move from one place to the other, like this furry monster walking from one side of the screen to the other in real life. The thing about motion is that when used wrong, it can actually make the experience worse. So let's look at this example. Like almost everyone, I've been obsessing over charts with COVID 19 data this year. And as I live in Canada, I always come across this one from a Canadian newspaper. Notice how when we switch from total to breakdown, the total yellow area slides down as the breakdown areas slide up. This makes it really hard for my brain to understand what the relation between one dataset and the other is. It should be clear that the breakdown represents a breakdown of total by the deaths, recovered, and active cases. But because the total area disappears when I change the breakdown, it feels as if the two datasets were not related at all. So let's have a look at how our perception changes if we keep the total area there and just slide down the areas related to the breakdown. The relation does feel a bit clearer, right? But to be honest, this is a great example of when using a fancy animation is not ideal. So let's compare it with the final alternative. Here, when switching between the breakdown and the total, we have a simple fade that reveals and hides the layers of data. This is great because it makes it obvious that these layers sum up to form the total, and my brain does not have to follow some lines moving randomly to try to understand what's going on. It's just there. There are, of course, situations where motion can drastically improve your perception of what's going on and help you understand the data. Let's have a look at another example. Here we have a chart that compares the number of sales from this year with the same period of last year. We can choose which period we would like to compare, this week, this month, or this quarter. Notice how when comparing this quarter to last year's quarter, the line actually that is red. But when we switch to this week, the line becomes green, as this week, compared to the same week last year, had more sales. The animation here helps us understand that the data lives in a timeline. When we choose a period to analyze, we zoom into that period, making it clear that, it belongs in the timeline. It is part of that context. This is another interesting example. In this chart, we show the number of page views in the last 10 minutes. We have 10 bars, one for each minute in the last 10 minutes. As we receive more data, the bar that represents what's happening now keeps growing. And when the minute is over and a new minute begins, it pushes all of the other bars to the side, making way for itself. Once again, the animation here helps us understand what's going on. Uh, Another thing that I would like us to talk about is how to deal with data restrictions because of course that we live in the real world, not everything is perfect, and sometimes you really want to create something that is visually interesting and delightful for people to play around and explore the data, but not necessarily you do have all of the information that you would need or everything that you would like, so you have to use a bit of creativity in those sorts of situations. So we were recently working in this customer behavior component. This was our initial draft. The idea here is that we would have these moving particle buckets for people with active cards, checking out, or that purchased something in the last 10 minutes. It would be super cool if we could see those particles swimming around there and jumping from one petri dish to the next one as people went through the sales funnel. The problem was that we did not actually have the data necessary to track what each individual was doing. Instead, the data that we could get for this component was something like this. As you can see, we only have one number for each one of the buckets. No way of knowing which one of the little microbes jumped from one petri dish to the next one. So we thought maybe we could implement the animation of the microbe jumping from a random direction into the bucket when the number increases. And even though it did seem like a good idea, it could easily get super messy. Imagine that we have hundreds of people visiting the website or thousands of people visiting the website. I mean, this could look kind of cool, like, some sort of evil blobs floating around there, but it doesn't actually help me understand how many people are at each step and how the flow is going. So that was not going to work. This was our second draft, and I actually think that this one is actually much better. We have three circles with different sizes that are easy to compare, so we can quickly, at a glance, see if we have more visitors with active cards or people that already purchased something. We can make it work with our data as well. Let's say that the first time that we receive the data, total checkouts is 15. And the next time we receive the data, total checkouts jumps to 17. This means for sure that 2 people are now in checkout and are new people in the checkout step. So since we know that the increment was 2, we can trigger an animation of 2 running dots going from the active cards bucket to the checking out bucket. And we can do the same thing if the number of purchases increased. In this case, we had one more purchase, so we trigger an animation from checking out to purchased. So let's see how we can implement that with SVG and Z3. But first, a really quick 2-minute SVG refresher. So SVGs work really similar to HTML. You create a markup, a tag for SVG, and you define a view box. The view box is kind of like a window for looking into the SVG world. The first 2 numbers are that origin point, that little red dots there. And from the origin point, you define the width and the height. And everything in SVGs are always X and Y coordinates that go from the top to bottom and from left to right. Inside of the SVG tag, you can define multiple tags for different kinds of shapes. So for example, you can define a polygon by creating a polygon tag and passing in a sequence of points that are X and Y coordinates for each of the points that create a polygon. Or rectangles, where you pass in an X and Y coordinates for the origin point, and then from there you define the width and height of that rectangle. You can create circles in a similar way. The only difference here is that you have CX and CY to define the center X and center Y of the origin point. And from there, you specify R for radius for how big that circle is going to be. Finally, you have paths, which are by far the most powerful way of creating shapes in SVG. With paths, you can create any other shape. So it works kind of like if you had an imaginary pen on top of the SVG, and then you pass to this pen a sequence of commands, like for example, move to this point, and from there, draw a straight line to X and Y, and from there, a curved line to X and Y, etc., etc. It can be a bit hard to memorize all of those commands, so thankfully there are lots of applications to help us draw SVG paths really easily. Things like Inkscape, Illustrator, SketchUp. But if you'd like to deeply understand how paths work, I really recommend this nice article by Jacob Jenkov that you can find on this link, bit.ly/svgpath. The thing about these automatically generated SVGs, though, is that they tend to be super messy. So we will want to run it through some sort of optimization to make something like this into something like this. And for that, you do have the command line the command line tool SVGO, or its website version SVGOMG, where you can literally copy the SVG code, paste it in, and copy the result out. Finally, when you have your SVGs properly optimized, you can apply CSS classes to it. And there are some properties that are specific to SVG elements, like fill instead of background color or stroke instead of border. Another cool thing that you can do is reuse your shapes instead of creating them over and over again. This is especially good for when you have complex groups of shapes that are being reused multiple times in the same screen. And you can even apply different CSS classes to it to customize each one of the instances of the group that you are reusing. So, less than 2 minutes. Now that the basics are covered, we can start talking about the cool part, which is D3. And even though D3 is cool, and we have all seen those fantastic examples of what can be created with it, it can be super difficult and overwhelming to know where to start. I mean, this is a screenshot from Z3's API reference in their GitHub, and look at the size of this thing. Z3 is a really complete tool, and it has all sorts of methods that you can use to treat the data, bind it to the DOM, etc., etc., etc. But since we're using React to do all of the DOM manipulation for us, we should probably define what we are not going to use from Z3. And that would be things like Z3 selection. This module works in a way that is pretty similar to what you would expect from jQuery, by selecting DOM nodes directly and transforming them based on a dataset. We do not want to use this module, as we'll be letting React do what it does best, take care of the virtual DOM in a performant way, and instead we'll use Z3 for what it does best, for being a toolbox to help us with math utility functions and layout calculations. So, no Z3 selections. A perfect example of the things that we are going to use is Z3 scales. Scales are functions that map from an inputs domain to an output range. So these functions are like the most important things that Z3 offers, along with the layout calculation stuff, but this is definitely like top one when you start learning it. So let's have a look at how this example that you can see on the screen now would look in code. We have an inputs array with some sample data. We can then use D3's extend function to extract the minimum and maximum value of the circles on the screen. And we can then use the function to get the CX position of each circle. So the first time that map runs, it's going to call the xScale function by passing it 0, because that's the value that we have in our inputs array. And we are going to retrieve back 0 pixels. The next time that it runs, we are going to pass in 250 and retrieve 170 pixels. And the last time that it runs, we are going to pass in 500 and get back 330 pixels. So this is super powerful for you to map some data with the available screen space that you have. So going back to the customer's behavior chart, now that we know how scales work, we can explore how to change the size of the circles by using a Z3 scale. The first example that we saw was a linear scale, but using a linear scale for calculating the radius of a circle is not the best, as we humans, we tend to interpret the data, to interpret the area to reflect the value of the data and not simply the radius. So instead of using a linear scale, we should use a scale square root so that the area of the circle reflects the data and not simply the radius. We can then use the radius scale to calculate the radius of each circle depending on the data. This is nice, but we are not animating the changes in the radius size yet, so it looks kind of, not smooth. Let's fix that by plugging in React Spring. The first thing that we do is import use springs, animated, and config from React Spring. And then we set up the animation by using the use springs hook. It works something like this. The first argument is the number of springs or animations that we are going to create. And the second argument is a list of objects describing each animation. It is here where we tell React Spring to watch for to what properties it should watch out for changes in order to animate. In this case, is the radius property, where we'll be using the radius scale to get the value based on the data points. So every time that the data point changes, we are going to call the radius scale again, and use springs is going to be aware of those changes so that we can actually see the animation on the screen. Then we have a config that we are going to pass in config molasses that we are also importing from the package. And this is just one of the default configurations that they offer in the library. These configs are where you can define things like mass, tension, friction, because React Spring creates these animations based on Spring physics, which I think is super nice. It's a really cool alternative to, old school time-based animation. But if you want to actually learn more deeply how Spring physics work, I highly recommend Josh Kumol's article, A Gentle Introduction to Spring Physics, that you can find on this link, bit.ly/spring-physics. I really love this article. It's full of these really cute animations that you can interact with to understand what each one of those properties do, like the mass, the friction, the tension, etc. So once we have the radius springs prepared, we just have to render it. And for that, we replace our regular circle tag with a animated dot circle tag, animated being the element that we imported from the library. And instead of calculating the radius directly, we get the radius from the radius springs, the constant that we created before. Finally, we can implement the running dots animation when we fetch new data, the one that plays when we have an increment in the data that was fetched. Similar to what we did before, we'll implement the animation with the use springs hook. To define the number of dots that should be rendered on the screen, though, we have to keep track of the data changes. And for that, we can use a custom hook called use previous. So basically what it does is that every time that a value changes, it saves the previous value in a variable. So we can always have access to the current value and the previous value. Now that we have a way of keeping track of the previous value, we can observe for changes in our data by using a use effect hook that has data as a dependency. Inside that hook, the first thing we do before anything else is check if the count has increased, because if it didn't, we don't actually want to trigger any animation. Then we calculate the increment size by comparing the current count with the previous count. This increment will be used to define how many running dots we should render on the screen. The animation happens quite fast though, so we can't actually tell the difference once the number of running dots is too big. I mean, it's easy to count when there are like 1, 2, 5, maybe 10 running dots, but when it's a big increment like 100, 200, you can actually count them. So we can take advantage of that for a quick performance gain. Since we can't tell if there are 50, 100, or 2000 running dots, we can actually clamp the increment to never be more than max circles per bucket. This means that we will never render more circle tags in the DOM than what's allowed by this variable. We can then create an array of objects that we will use in the springs animation. By using an array method and passing in the increment size, we can create an array of the length of our increment and fill it with an object that describes the animation for each one of the dots. There is a lot happening on this block, so let's have a closer look. If you create an array by using an array method and passing in a number, it's going to create an array, an empty array, of that that length that you passed in. You can then use the fill method to fill it with any kind of value. So it can be nulls, it can be strings, or in our case, it can be objects. So each object in the array is going to be the same. A from CX, where we store the initial position of the running dot when the animation starts playing. In this case, it will start inside of the checking out bucket. Then a to CX, where we store the final position of the running dot when the animation stops. In this case, the animation will finish when the dot is inside of the purchased bucket. Finally, we have a radius for each dot. But remember that we talked about not being able to notice the difference when there are lots of running dots on the screen. So we do need a way to signal when the increment is big or small that is not based on the quantity of dots on the screen. So we can use the radius of the running dots for that. And that's exactly what we're doing there. We are calling a get running dots radius and passing in the increment. And what this method does is just it checks if the increment is big, return a big radius. If the increment is small, return a small radius. Finally, we can use the array of objects that we just created to actually implement the animation inside of the use springs hook. It's similar to what we did before, but there are a couple of differences. The first thing to notice is that we are applying a delay to each one of the dots based on its index. If we didn't do that, all of the dots would run at the exact same time and would be on top of each other. So we wouldn't actually be able to see the many dots because since they are running at the same time and on top of each other, we would only ever see one dot running at a time. By applying this delay, we can create this trail effect, like if one dot was following the previous one. Then, instead of just animating a value every time that it changes, we are defining where the animation should start and when the animation should end, with the from and to objects. Each of the properties inside of these objects will be animated. Here's how it looks in the end. Small dots for small increments. The circles of the buckets change in size depending on the amount of people in each step. And if we increase the increment size, you can see that the running dots become much bigger. Yeah. SVGs are super cool, but there are lots of situations where it makes much more sense for us to use just regular plain HTML. Let's look at this example. This component is a heat map for the total sessions on a website per hour in a day. Each green rectangle represents an hour of sessions. If there are more sessions, the more vibrant the green gets. If there are less sessions, the less vibrant the green gets. This is super easy to implement with HTML. Using something like Flexbox, we can make sure that all of the rectangles get rendered beside each other, creating a line, instead of us having to manually pass down the X and Y coordinates to each one of these rectangles, if it was implemented in SVG. So the structure of this component would be something like this. We receive data with an hour per day as props, and you may think that hours per day is always going to be 24, but we do have to take into account 23 and 25-hour days when we change from standard to daylight savings time. We can then calculate the width of each green block by dividing the component width by the amount of hours in that day. And then we get the minimum and maximum values from the data by using D3's extend method again. And finally, we create a color scale. A color scale is basically a scale linear that ranges from the lightest color to the darkest color. Really similar to what we were doing before. The only difference here is that we call interpolate and pass in the interpolate RGB method that we can also import from D3 to retrieve a color string instead of just a number. And because it's just HTML, the markup is pretty standard. We toggle a data point is active CSS class on hover, or when we tab into the green block. And that CSS class uses transitions on properties like transform, scale, and box shadow to create a little animation when we hover or tab on a cell of the little cell popping up a little bit. And then we have a div with a tab index of 0, so it's accessible by keyboard. And also super important, area labeled by linking to the tooltip ID, so that screen readers can actually read the content inside of the tooltip when we focus on a cell. We then have multiple event handlers to display and hide the tooltip when we interact with each cell, and an inline style that sets the width based on the calculation that we did before, and also the background color using the color scale and passing in the value of the data point for that specific hour. So, a little note on performance and reusability. When dealing with animations, it's really important to be always measuring the performance to catch potential problems. For example, when we first implemented the customer behavior chart, we noticed that if we left it running for a while, the performance would drastically drop. And that was happening because the running dots animation, the dots when they were finished running, they were never actually being cleared from the DOM. They were never actually being removed. So it kept building up, causing the horrible performance loss. If you look at the first screenshot, we had something like 600 circles being rendered in the DOM at the same time, which was solved after we fixed the problem. And to solve that, one simple change actually was necessary. In the Spring config, we can define a function to be called on rest. That basically means that that function that you pass in is going to be called when the animation stops. So in this case, we just had to reset all of the new orders when the animation was finished. Similarly, in our initial implementation of the heat map, we had lots of inline anonymous arrow functions in the event handlers. And this is not good because every time that the component renders, all of those inline arrow functions are recreated. And to avoid that, what we should do instead is extract that markup into a separate component and pass down all of the functions and their arguments as props so we can avoid all of those inline arrow functions. Another important thing to keep in mind is how expensive layout calculations can be. Let's have a look at this example. This is a pretty common situation. You have a dashboard where you can see lots of cards with different data charts. But as we've seen, SVGs are not so great at optimizing for responsive layouts. They just dumbly shrink down like images, which is not ideal. So usually what ends up happening is that we have some sort of method to calculate the available drawing space that the SVG is going to use to draw itself. It can be something like this. Get element method that receives the DOM element and calls get bounding clients rect to retrieve the available width and height. And then we can even have a custom hook, something like use element size, that uses a resize observer to update the width and height every time that the element size changes. This is great, not only because the resize observer is better than window resize events in terms of performance, but also because it will trigger when the element size changes due to page layout changes that are not necessarily triggered by window resizes. Think of things like, sliding panels, for example. Going back to the dashboard though, we might be tempted to use the hook in the chart component level. So every time that we render the chart, we don't have to worry about its size. It's just going to measure the available space and render itself. But if we notice here, all of the charts on this page actually have the same size. So this means that only on page load, we would be querying the DOM for the same information 5 times. Suppose that we include another element on the page 6 times. Or if we include a sliding panel like we mentioned before, or something else that causes the page layout to change, every time that we open and close that sliding panel, it's 5 times and then more 5 times. So that's definitely not the best approach. What we should do in this kind of situation instead is move the layout calculation to the top component, the page level component, so that we can fetch it once for the first chart. As you can see there, I'm using that hook and passing down the component that we have in the ref, chart size ref, only for the first metric. I already have the width and height based on the first chart, so I can just pass it down so all of the other components being rendered in the page. Even better than that, we can make the width and height of these components optional so that if we pass it in, they use it. But if we don't, then they calculate the layouts based on the available space and take care of it by themselves. And lastly, a note on accessibility. Even though animations are super cool, super exciting, and many times they do help us tell a story, it can also be a horrible experience for people that are sensitive to motion and can get dizzy by watching things dance around in the screen. Many operational systems allow the user to turn on a reduced motion option to help with this dizziness. And us as developers, we should definitely check if that option is turned on and turn off our animations if it is. In our projects, we have a use reduced motion hook that takes advantage of window match media to check if the user prefers reduced motion or not and return true or false accordingly. This plays really nicely with React Spring as it accepts an immediate prop that when set to true basically turns off the animation, meaning that it's going to go immediately to the last step of the animation instead of just playing it. All right, so thank you so much for following along today. And if you like this talk, I would like to remind you that I'll be giving a 2-hour webinar on creating custom data viz with D3 and React on January 21st. And you can get tickets at Laracon's website. As I mentioned before, if you have any doubts, comments, or questions, please do reach out to me on Twitter. And I'll also post the slides of the presentation there. My username is Krystal Campioni. And we are hiring. We will hire 2021 developers in 2021. So if you'd like to come work with us, feel free to reach out to me directly or visit the careers site at Shopify. Thank you so much.